So I'm going to go back through this ice chart, pausing on a few points. So think of an ice chart as just a mathematical way of solving a problem. So there was this big thing that came out a few years ago about Common Core and how everyone's having a hard time understanding how to solve things with Common Core, because what they learned, it was something like, when you subtract whatever number you're going to subtract, I don't know, 19. You would take the 10, borrow, like that, and then you can solve it. So that was how it used to be taught, and everyone was taught the same thing. And with Common Core, you learned, oh, well, no, you want to think of it as a group. So let's think of this as like a group of 10. You know what I mean? So there's a method. So that's what a nice chart is. It's just a method, and it's the method that we use in chemistry. This comes back in biology. It's actually biochemistry, and it comes back in upper level biochemistry. There are other methods that are different and more complicated once you get there. So ice chart, ICE. I've also seen this as a rice chart, for R for reaction. I've also seen this as an IC chart, where E is where you make sure that everything is in molarity. I've seen this as a mice chart where everything is in, it's another way of remembering that everything's in molarity. So I've seen it a few different ways. The key part is that I stands for initial. So this is like when you start the reaction and nothing happened, or the tiniest moment before everything starts happening. That's this one. This one is how the reaction changes all the way and up until the point you get to that equilibrium. Remember that equilibrium does not mean equal amounts of this and this. Equilibrium is the point at which you've made a certain proportion of products to reactants, and the reaction wants to stay at that proportion. Products will, as the reactants continue making products, the products then start remaking reactants to keep that ratio. The system's able to tell what the ratio is when you've got a whole lot of these reactions going on, and it's going to keep it at it. It's kind of amazing. So initially, remember, you don't have any product because the reaction hasn't started yet. So that's why that's 0, like there's none. So I'm just going to go ahead and throw that comment out there also. Now, before you fill in the ice chart, and this is really, really hard to skip the process and to not think it through. But what you actually want to do before you even set it up, everyone jumps to it, the ice chart, you want to actually write the K expression to the side. And this is why. When you finish the ice chart and you get all your numbers in, your brain is going to say, okay, what's next? And then you've got a blank spot. If you have the K already ready and waiting, because you set it up first, when you get done with the equilibrium, you glance around, you see the K, and you start plugging things into K, which is kind of the middle step. So there's like a mental step to this. And if you always write the K first of all, you're less likely to miss things like coefficients. And then it just helps you so that you don't stop the reaction halfway or the math halfway and not continue it. So always products over reactants, HI, H2, I2. And then those are raised to their coefficients, that's a 2, and there's nothing else in here. So now when we get done here, whatever shows up in this section is what we're going to use to fill those pieces of information. So now we're going to fill out the ice chart. Always put the 0 for the products over there, unless someone came along and like put products in your reaction or something. But so that's 0. They can do that too, right? People do that. So the initial, this isn't actually the question I meant for it to be. The question will say something like initially, or when the reaction begins, or something with that like beginning tone to it, and it'll give you an amount. So maybe it'll say initially you have 1 molarity of each reactant. Well, that means that you put a 1 here because that's how much you have of each of them. So 1 and 1. You don't have to put the M in if you don't like. Probably should have written it as 1.00 because you know sig figs and all. So 1.00. Now here's the key step. Because your reactants here are making products, they both are being used together to make products, right? You're losing them. So these are always minuses. And because you're making products, you're always gaining products. So the left side always has to be minus, and the right side always has to be a plus. Then we pick a random variable. Almost all the time there's x's. Sometimes there's another version of an ice chart that you use in, not another version, you usually use the ice charts, but there's another math step where you use these ice charts. And sometimes you can see people will use s's, but I highly recommend keeping with the same variable the whole time. So we're going to keep with x's. And this, again, we have to pay attention to coefficients. Since there's 1, that's minus basically 1x. Understood 1 minus 1x, and then this is an understood 2x. Now, equilibrium is saying add or sum. So it's just like a regular summing thing. It should have variables in it, minus x, 1 minus x, and then 2x. So really this column, it's because you start with 0 most of the time, it's going to just be the 2x or the x, whatever is on that right-hand side. So now this is where everyone's like, okay, I'm done. And you're like, what do I do next? And so that's why I go ahead and glance over on that right-hand side, see if the problem gives any information. It does. It tells us what k is. It's 50.5. Now we're going to plug it all in. So k is equal to, I have 2x. So you'll notice I'm going to put the 2x there. And then I have 1 minus x that goes here. And then I have 1 minus x, and that'll go over here. Just make sure you put the stuff in the right spot. And then 1 minus 1.00 minus x and 1.00 minus x equals 50.5. Now, I have another video where I get all into the math of this. If you were doing this all by hand, yes, you would FOIL front, outer, inner, last. And you would have like x squared minus 2x minus 1. Plus, on the top, yeah, that 2, it applies to that and that. But we do kind of have some math stuff to help you be able to work these so you don't have to deal with quadratic formulas. But you need to get everything to this point. Once you get to this point, you'll be able to solve that x is something, some number. Once you do that, you can figure out equilibrium concentrations. If you know x, then that means you know this number because it's 2 times x, and it also means you know this number because it's 1 minus x, and you know this number because it's 1 minus x. So I want to show you something else about this.